have an exterior angle. What do I know about exterior angles and the remote interior angles? Ty. They add up to the exterior. So we basically have 70 plus x equals 120. Subtract 70 from both sides, and we're going to have x equals 50 degrees. Most of us had that one. Most of us had this one because there's alternate methods too. You could have realized that there's 180 degrees in here. So if this is 120, does anyone know what this measure of angle would be? It would be 60. And then we go, oh, you know what? 180 minus 60 minus 70 equals 50. So we got 2 ways to get to it. I think the remote interior is a little quicker, especially for this one. The remote interior angles are going to really help us solve this one. Because what I'm going to point out really, really quick, what kind of triangle is ABD? It's an isosceles triangle. It's obtuse, but my more important part is isosceles triangle. What do we know about base angles of an isosceles triangle?
They equal each other.
They're equal each other. Now, here's going to be a question for the test on Friday. If I have two sides that are congruent, is it the theorem or the converse that says the angles are also congruent? Is it the theorem or the converse that goes from side to base angle? If you're not sure, look it up. Because you'll have it for the test. You better, if it either said the answer already or you're looking it up. One of two things. My question is, if I give you the sides and you have to prove the angles are congruent, are you using the theorem or the converse? Who can raise your hand with confidence? Maybe you looked it up. Maybe you just know it. Yeah. It is the theorem, actually. If you look it up, the theorem says if the sides are congruent, then the angles are congruent. The converse says if the angles are congruent, then... Here's the way I remember it. When you look for an isosceles triangle, you're looking for two congruent sides, right? So the theorem starts with two congruent sides. It's just the isosceles triangle theorem. We know that it has two sides. The converse is if you have base angles congruent, then you can make it isosceles. That is what it is. So this would be the theorem, would say 1 is equal to 2. Well, I know 1 is 35. And so 2 is 35. What's 35 plus 35? 70. That's going to make angle 3 70 degrees. Notice how I could skip this angle. If you didn't know that, you might have actually figured out that angle. That angle is 110, but I'm going to skip right to the exterior angle. All right, now I have this is 70 degrees. What do I know about angle 5 and angle 4? They're congruent. Is that the theorem or the converse that goes from sides to angles? Theorem, I just said that, right? Sides to angles is the theorem. So if you're given sides, you're going to use the theorem to say that 5 and 4 are congruent. A lot of us need to go back into those sheets and study that stuff. All right, so those are two congruent things. Now, in a triangle, we have 180 degrees, right, I think? Yeah. So if I did 180 degrees minus 70, that equals 110 degrees. Does that mean both of those angles are 110 degrees? No. You have to split it. And if they're equal, so we're going to split it equally, so I'm going to divide by 2. What is the measure of both of those angles? 55. What's 55 degrees plus 35 degrees? Wow. Are we okay? Do we need to stand up? It's 90 degrees. The correct answer should have been 90 degrees. A lot of us did not get that. I think a lot of us guessed 85 or came up with an error somewhere in 85. I'm not taking any points. That's a good question. It's a tough bell work one because we haven't seen it for a while. But now that we saw it, this is something that could show up on the test. Because I used isosceles triangles. And not to mention, if you remember this rule, makes it really, really easy. If I didn't remember this rule, I could still get there. I go, okay, 180, this would be 110. That would make this 70. I can then split it. This is definitely something that can show up on the test. All right, questions on the bell work? Then let's go over questions on the homework. Yeah? Number 9. I think I have it up here, maybe. Number 9 says, determine whether there's enough information to show that triangles are congruent. If so, state a postulate theorem that you would use. Well, number 9 has 2 triangles. So I'm picturing this triangle here, which has these marks on it. So I can go down below and I can write that triangle. I have J, M, K, where K had double tick marks. This one had single tick marks. I'll do in red the other triangle. Right there, we can see it as a double tick mark and a single tick mark as well. So that's going to be my other one. We'll try to draw that one. This was the M, J, L, double tick mark, single tick mark. Now, right now, it's not enough information because it has to be side, 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 angle, side, angle, side, angle, 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 side, or HL. Remember, think about this for a second. I want to use HL. What kind of triangle do I have to use HL? Hang on. Matthew? Right? We have to have a right triangle. So could I use HL on this one? No. Okay, so I have 2 angles. So now I have to look for, is there a reflexive side? Is there a side or an angle that they share? Well, do you see this JM? That it shares both of those? So I can put a tick mark on JM, which would transfer to all of these, which would be angle, angle, side. Because it's 2 angles and the non-included side. Good? All right, more questions. Go. Sure. All right. If we look at this last one, see this fact right here? I have to go from 2 triangles to show that angle A is congruent to angle E. Notice it doesn't say I have to show triangles are congruent, but do you see triangles up there? That probably means I'm going to show triangles are congruent. And if I'm going one step further, I'm going to have to use CPCTC. Anytime we have congruent triangles, and I'm not trying to prove they're congruent, I'm trying to prove like segments or angles are congruent, we're probably going to use CPCTC. So let's first kind of draw these triangles off to the side. So I have kind of this big triangle here. That one. Let's draw that one. And make sure we put the proper tick marks on it. So right now I have a tick mark right here. That's CDA. And then the other triangle I'm going to look at is this BCE one here that has that tick mark right here. So I'll draw that. I don't know if I gave myself enough room. I just gave myself enough room. All right, so this triangle here is going to be BCE. And they have a tick mark right there. Okay, that's what the drawing gave me. Now let's go through and see what other givens we have. Okay, so we have given 1. AC is congruent to EC. AC is congruent to EC. So we can add more tick marks to these. I can add a double tick mark here, a double tick mark here. They also give me CB is congruent to CD. CB, oh, I already have that one marked. Cool, so that's my given. Do we have a postulate that says side, side? No. So now I'm looking for, okay, could be maybe it's side, angle, side, or it's side, side, side. Those are the only 2 things it could be. The only thing that has 2 sides in it is side, angle, side, or side, side, side. Now, here's the nice thing about these proofs. You already know what you're looking for. If I'm looking for side, 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 I'd have to show that BE is congruent to AD. Do they share those entire lengths between those 2 triangles? No. Okay, so let's look at something else. Let's look at angle C. Do they share angle C? Is angle C the exact same angle in both of those triangles?
Yes.
Yes. So I could go ahead and put a mark here, which would mean I could put a mark here, which means I can put a mark here. I now have side, angle, side. So my step 2 is to say that those 2 triangles are congruent. So I'm going to say something like triangle A, what do we got here? ACD, ACDC, is congruent to ECB. And that would be side, angle, side. And as soon as I say these two triangles are congruent, that means every part is congruent by CPCTC. So I could now say BE is congruent to AD. I could say D is congruent to B. I could say A is congruent to E. So let's see what their question is. Their question is A is congruent to E. But notice all of the different things I can answer as soon as I say that these two triangles are congruent. As soon as I say they're congruent, everything's congruent by CPCTC. That corresponding parts of congruent triangles are congruent. Are kapukatika. Just rolls off the tongue. I don't know why more people don't say it. It's kapukatika. So easy. All right. So my step 3 is to go, you know what? Angle A is congruent to angle E by kapukatika. So it turns out, even though I had to prove a triangle congruent, and I had to use CPCTC, it's still a really short proof. It just required one step. You understand that they share a angle. Yeah, Julian. Did I?
Yeah, you had to reflex it.
Yeah.
C.
Yes.
Oh, I completely missed. Yep, you are 100% right. I skipped a step, didn't I? Sometimes I do the same thing you guys do, where you write something above and you forget to give the reason. So I actually missed an entire step. Did I ever say C was congruent to C? No. Did I draw in the picture? That's why you draw in the picture. So if I would have skipped that step as a normal student and I didn't write anything on the picture, that's a full point off. If I drew it in the picture, that's a half point off, because that just means like you did your work, you just forgot to write it in there. It happens. It happens. I still have to take points off because you didn't do it perfectly. But to get that perfect score instead of the half off, I'd go C is congruent to angle C by reflexive. And this would be 3, this would be 4, and now we'd be done. Good. Yeah?
How many points would you be taking off if you forget like numbers on the proof?
I take a half point off now.
Half point?
Yeah. Just don't. Just write your numbers. All right? So here's the reason why it's important to have numbers. You'll notice at times where I don't put these lines on there. If you don't have lines on there, you can't see what lines up without having those numbers. So I'm prepping you for times when you don't have those spaces. It's the way that you can relay information to someone in a nice, organized fashion without having to draw lines under everything. All right, other questions? All right, then I have a quick question for you. I handed out those reviews